let's move on to database, right? So I want to create a database, let's say Microsoft SQL Server instance, and then let's see how easy or difficult it is. So again, go back to Docker Hub. So I have SQL Server container here. So we can download this MS SQL Server Windows Developer Edition. And again, we fall back on the help here. So let's run this Docker, right? It's just one command for everything. So I have this command. So it says Docker run and it says detached mode. And the port mapping is 1433 So what I'm saying is basically you map the default SQL Server port on the container to 1433 on my host machine. And then I'm actually specifying some environment variables in which the SA password. So when you say SA password, the default user is assumed as SA. So let me give something which is acceptable in terms of complexity. Maybe a test 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, right? And then accept EULA. Of course, it has to be yes. And then the name of the container. So sorry, name of the image. So Microsoft.com, Microsoft slash so mcr dot Microsoft dot com MSSQL Server Windows Developer and then colon 2017 hyphen latest. Okay, I need to give the tag because without the tag, it's going to pick up the latest, and I don't want this to download here. The image is already downloaded. I want to make use of that. So, and it's as you can see, it's 14 GB. So I don't want to try that in this demo. So let's see what happens. So it's actually saying, oops, there is cr.microsoft.com slash MSSQL server dash Windows developer colon. It's saying it's not able to find the image. Let me verify whether I got the spelling correct. Ah, it's just Microsoft.com. That's why. Microsoft, I think what I had copied from the help from Docker Hub was actually correct. I just needed to add the tag. Okay, so there you go. So it actually is now starting a Docker instance. It just takes a few seconds, much faster than you could actually imagine installing it on your own, even within an image, because you need to actually install SQL Server. It's a long-term process. Some people who have worked with SQL Server, you already know. So my Docker instance or container is already running. As you can see, there is this Microsoft latest um, SQL Server is already running. So how do I test this now? So let me open my Visual Studio. Right, as you already saw, I have mapped the container default SQL Server port to my local host port. So I can actually should be able to connect from my SQL Server IDE. Right. So, okay, let's open up a new connection. So I'm going to say it's a local server because it's available on my local host. SQL Server authentication. Username is SA. Test 1, 2, 3, 4, 5. Let's say connect. Wow, there you go. So I was able to connect to the database, right? So, but as you can see, it's an empty database. So it has nothing in it. It's a fresh install. And as you already might have guessed already, if you actually want to build um, your own CI pipelines or even in production, whenever you install SQL Server, you always want to actually retain the data or you want to create the data. So one way to do that is basically you can actually create your own scripts of initializing the database. So you can actually see, for example, I have this. I want to create an inventory database and then create a products table. So I can do this and then have this SQL um, command run during the creation of the image. Soon after it's actually run, the container is started, we can run this and have our database created. And what if you actually want to retain the data itself, right? So let's say I make some changes here. So to this, let's say I actually add a new database, right? And then if I actually close this, if I come here and I stop this container, right? Let me stop 04C. Stop. Let me disconnect from here. Okay. And I also want to remove the container. So docker rm 04C. So when I remove the container, even though I have the image here, right, the SQL Server developer, that's a plain vanilla image. I mean, whatever I had created, my database is all gone. So how do I actually retain data when I'm actually creating, no, when I want to repeat my test cycles or in the production, um, in production where I want to actually restore the database. So Docker does give you an option for you to basically attach DBs. You can attach an existing DB to a running container or when you create a container. So if you actually, again, let's go back to the help file, it's already present there. So if you actually saying like, so if you're trying to attach DBs in an environment in a Docker file or a Docker Compose file, you can on Windows use this format. So they already given this format. So and I have already typed it um, in a Docker file. All right. So basically, again, the reason I typed it was like, no, I didn't want to make any typos, and moreover, basically there is a lot of missing information, especially with Windows containers. For example, if you actually go back to the documentation, it says that you need to use DB files with a double slash. However, the double slash won't work, and you need actually double slash, basically four slashes, backward slashes, and otherwise you get into all kind of troubles. So I mean, I went through all that, and so I have this ready made now. So let's go through this Docker file. And see what are the steps inside. So basically, again, pull the image from um, your Docker Hub, and then I'm actually creating a folder called SQL Data inside of my container. So I'm doing a make directory SQL Data, and then I'm copying. So I already have some inventory database which I had collected from my previous examples. So I have an inventory MDF and an ILDF log file already. So I'm actually copying those inventory database files into my SQL data. And of course, I can actually set the environment variables here also in the Docker file. So we can do all this. And then I'm setting the password. And here, as you can see, I'm using this attached DBs where I'm actually saying I need to create a database called inventory. And the files for that will be in the SQL data folder within the container. It's called inventory.mdf and then inventory.ldf. And finally, I'm exposing a port. So now I want to build this image. So before we go there, so let's remove any older images. Docker remove MySQL images RMI MySQL. Okay, I need to give a tag, image ID, not the tag. So that is going to be 099. Okay, so these are all the layers which got created as we were playing around with that um, the previous demo. So ignore that for now. So now I have Docker images. So I'm actually only having the default SQL Server developer image. So now I'm actually going to build. So I can see, as you can see, I have my docker file.rb here. So what I can do now is docker build -t. I can actually say MySQL demo build demo, and then I actually want to say file docker file dot db, and I want to say the current directory for all the data what it needs to pick, for example the inventory and all those things, and then for all practical purposes the default directory is the current directory, so build everything in my default directory. So there you go. It started with step one. Basically, it's pulling the SQL Server image, and because we already have that, that step is done. Now it's doing um, basically creating a directory called SQL data inside of the container. It did create a directory, and then it's now copying the inventory database into SQL data directory, and it's running the container, and then basically it's setting some environment variables. Sorry, it's not running a container, but basically it's setting all these environment variables. As you can see, we only set the environment variables here called attach DBs. So when we actually run this image, um, we can basically utilize the environment variables and it'll start running. So to run, we need to use another command. So basically, I just need to run docker run. So what I'm saying here is like, Docker run in detached mode, and then I need a port mapping on 1433, which is exposed in the container to be mapped to my local port. And then here my SQL build demo, right? So let me show you actually before that, Docker PS. As you can see, only my IAS website is running. I don't have any SQL Server container running. However, in Docker images, I have MySQL build demo, which got created from my previous build activity. So now let's, so Docker run -t -p hyphen p 1433 and then yeah, so my SQL Server repository name plus the tag name. It's now running. There you go. Now we do a Docker PS. It's going to show that there is a container with this MySQL build demo running. So now if I go back to my browser and then say local, sorry, we need to go back to my SQL Server here. Sorry, my Visual Studio, which has a SQL connection option. So I'm going to say SQL Server authentication, say test 1, 2, 3, 4, 5, and then connect. There you go. So when I actually open that now, As you can see, there is a new database called inventory, which I had already attached, right? So now we can actually use this as a stepping stone for my next demo. So in my next demo, I'm actually going to see how we can actually build a complete multi-tier application. So how can I actually create um, a full-blown UI which connects to a database and all in one shot, right? So let's see how to do that in next. Okay, so let's build a full-blown application. So let's take some ASP.NET example and then a real life example where the application actually talks to a database. In our case, it's going to be a SQL Server database. So I found this nice example on Syncfusion. So basically, this is a step-by-step example of how to build a ASP.NET Core using Visual Studio 2019. This is nothing to do with Docker. So this example just tells you how to build your application um, using ASP.NET Core 3.0 using Visual Studio 2019. So basically, what it says is like now you need to have a Visual Studio environment and then also access to a SQL Server. So the first step it actually does is like asking us to create a inventory management database. So basically, it says that you need to have a database called inventory and then basically some products in that. So basically a products table. So and then it has a step-by-step example of how you can create a ASP.NET Core application. And this is what I did. Although there is a link below where you can actually download the example from GitHub, I actually followed this application and then created my own ASP.NET application. So he asked you to create a new project and then basically get all the NuGet packages, generate all the scaffolding, so that now it creates the model view classes for you, and then finally use the connection string so that you can actually connect to a database which you created prior. So once all that is done, you can actually add the MVC controller, which will help you do the CRUD operations, right? So once you actually have all this set up, you can now run the application. So I have actually created that application and that's what I have here. So let me now open this up in my Visual Studio. So I'm going to open my inventory management application. So in here, I have this app setting.json, which has the connection string. And as you can see, I have actually set the server to local. So this application needs a database. So and then the database which I created using the Docker engine, um, right? So when I say Docker PS, there is already a SQL Server instance running, and then that's mapped to my local host on 433. So that should be applicable here. So all I need is basically indicate that it is a local host, and the database inventory, as I mentioned already in my previous example, I think it's already yeah, there you go. So we already have this connected, and then we have this inventory table also, right? So let's try to just run this as is from um, my Visual Studio. It's now connecting. Yeah, so it has basically the inventory management. So let's create some sample data. See, you can actually create, edit, and do all the CRUD operations. right? So and then the data is actually coming from the database which is on the SQL Server, right? So if you go back to close this application, go to SQL Server object, go to inventory, tables, products, and then you can actually view data, right? So the one which you actually entered is here already. So so now what we need to do is basically create an instance of IAS server and then compile this project, send the output of this to uh, our IAS server and make that as a default application, and then create a database. And then we already did that and connect that database to the newly created ASP.NET instance. Right? Let me close my Visual Studio now. So as we already saw, basically we have a Docker file for creating the database, and then we had already attached the DBs which contained the inventory database and then the products table, right? So similarly, we have a Docker file for compiling this as well, compiling the or building the image of the ASP.NET application and then sending the output of my inventory management application to the container, the ASP dot and the IAS server hosted inside the container. So for that, basically again, we do a pull from Microsoft.com. This time we are actually pulling a SDK 3.0 image. So it's interesting to see that we are actually building the app inside a container. So we are basically downloading SDK 3.0, and then whenever you actually do a pull, you can also tag it. So now we're actually saying that this as my build environment, set the working directory as SQL application inside the container. Um, just copy the project files which is there as part of this application. So there is this my inventory management CS project file that gets copied onto the app directory, and then we do a .NET restore. So .NET restore actually downloads all the dependency NuGet packages and make sure we have all the content, the dependencies downloaded. And pretty much we copy everything what we have here, um, basically the complete application, and then publish that uh, and then do a .NET publish and we do a release, and then the output folder is out folder. So once we actually build that out, we actually create or pull one more container which is now ASP.NET 3.0 based container. So we pull that image and create a container. Again, we actually set our working directory as app, and then see here we copy the output from the build environment image, the container, and then copy that out to my ASP.NET 3.0 based container. So again, just copy the output to app output. And finally, you set the entry point. So this actually tells you that my entry point for this application should be my ASP.NET DLL. So once we have that, basically all we need is just a command to know to basically build the ASP.NET image. So this is where it gets interesting. See, what we want is we don't want these things to basically be isolated. So I can compile this out and build an image. I can compile this um, database and I can also build another image. But how do I tie these together? How do I actually make sure that my ASP.NET application is actually talking to the newly created SQL database, right? So that is where we have the compose file. So if you see here, this is a compose file. Compose file is basically built for building. Basically, it composes the application. So you can have multi tiers of your .NET containers, and it not only builds everything together, it will also give an ability for you to tie all those into like one network. So everything works as like um, a complete isolated, fully functional unit, right? So if you see here, services are nothing but your images. So we are trying to build containers. So each container is having a name, and then that name actually is the name which is referenced by the other services as well. So if you see here, we are now trying to build DB first, and then the as we already saw with the build command, so we just need to give the same build parameters, but then the slightly the syntax is different now. So you have a YAML file with all these um, hierarchical parameters. So we have a build, and the context is a current directory, and then the Docker file is actually the Docker file.db. Finally, the port is like 143, and then the rest, the remaining actually is all um, like within the Docker file DB, which we have already seen, right? So similarly, we build another service or another container. Basically, we need to build that, and then we uh, the context is a current directory, and then this time we are referring a doctor.web file. So when you go to doctor.web file, I already mentioned to you that this is a basically a Docker file for building .NET ASP.NET 3.0 image, and we build that out. And then here, as we see, it says depends on. So when I say depends on, it actually this service depends on the DB service. So what this means is whenever Docker tries to up these services, it'll ensure that this particular service is up before it brings up the service which is dependent on that. Finally, we have a port mapping, which says that my local host 5000 is mapped to the internal port number 80. So now how do we build this? So it's just very easy. So I just do a Docker compose, and then point to the YAML file, the compose file, and then just do a build. So let's do that. Okay, so before that, let's see if there is any other images that needs to be cleaned out. Okay, so I don't need MySQL here. So let me remove the image. Okay, I need to force it. Let me stop my container. So remove. I'm deleting my container, which was created earlier, and then I'm deleting the image. Right. So if you see the images list, we just have. Okay, let's remove the untagged one as well. Images. Okay, so the multiple lines what you see here is basically it's all the different layers. So it's going to delete all the layers as well whenever you delete an image. Okay, so now we are clean. So now let's now build our images. So now when I say build, I'm going to actually use this compose file, and it's going to build both of these, right? It's building a DB. As I already mentioned, basically it started with the SQL Server image what we had. It's creating a SQL data directory, and it's going to copy the the content, basically the backup files or the database files, and then attaches them to the SQL Server instance. Okay, so I think it is done now. So as you can see, it finished the data layer, and then it started with the web layer. It actually built the image, as I had already explained, to actually um, build the project first. So the .NET restore and then .NET publish actually compiles the my inventory management project and then copies the output to another image, which is basically the ASP.NET 3.0 image. And once that is done, basically it sets the entry point and then it exits. So as I actually mentioned, basically this is um, just the build part, right? So if you want to, when you say build part, it's only the images. So let's see the images now. Say Docker images, it's going to actually um, give you two additional images. So if you see this, my inventory management DB and then my inventory management web are the two additional images which got created. If you actually see what is running, um, basically there's nothing running. Nothing should be running. So we have actually the images as I showed you. All we need to do now is basically use the same command, except that instead of build, we're going to use the up command, which means that basically both these instances actually needs to be um, started. So and as I already mentioned, because of the compose file and because of the depends on um, no settings, basically it takes care to start the database first and then the web. So basically your application should be ready to use once this is done. So let's start this. First the DB, as I said. Basically it's creating an instance of the DB1, and then it should in a while start the web instance as well, and it should kick off the website which we had actually configured to as a default website. So it might take a while. Okay, so DB is done, web is done. Basically it's attaching, as you can see. um, Basically it started the website and it started port 80, and then it's just uh, like hanging in there. So I think we should be ready now. So starting SQL Server, changing credentials, and then started the SQL Server. So it should be up and running now. Let's go back and then let's start localhost 5000 is the port, right? Oh, there you go. So we already have a product and this should be a functioning website. I can create product to. Okay, so there you go. It's a fully functional website. So it's all functioning. So as I mentioned, basically what Docker has done is like it's not only created two instances, two containers, and then it has also linked them. So the beauty is that you can refer these by names. So Docker does internal DNS server, and these services, these container instances can actually refer each other by its name. If you actually remember, we had actually given DB as the host name for SQL Server in our connection string in the web application which we created. So there should be two instances which is running. As you can see here, the two instances which is running. If you see, if you inspect one of them, yeah, 5, 3. The one thing which you would want to um, notice here is like basically the network, right? So if you see this network, there is my inventory management default which is got created, and this is for the compose file. So basically all the services within the compose file will get this network, and this is the default network attached to all the services. So now if you actually see, I'll list down Docker network ls. There you go. So there is my inventory management default network, which is network created by default. Or if you want to inspect that, 6F9 network. Okay, so this is the network. So as you can see, this network is actually having the containers. One of them is the DB, the other one is the web. And then if you see the the IP address and other things also actually are managed by this network, and this is the common gateway, so by which it can actually know talk to each other. Okay, so there you go. So we have working full-fledged application which is running on Docker and exposed only by the web service which we want the outside users to actually use. So everything else is shielded completely. Although the containers can talk to each other, none of the external host machines can actually look at the any of the services which is running within the containers. So it's kind of more secure than your regular approach without Docker. One last thing which I wanted to cover was basically I want to share um, my learnings. Basically I also started Dockers recently, learning Dockers recently, and um, I want to share like how my journey was. So basically, um, what you want is like what you want to know is like there is process isolation happening in Windows. All these points are for Windows 10 development or Windows 10 developer perspective. So if you're developing Dockers or if you're trying to learn Dockers on your Windows 10 desktop, you need to remember this. So the process isolation is via Hyper-V, which means that the processes are not visible in the task manager, and also you cannot directly talk to the processes from within the Hyper-V, which means that some of the Docker commands like the Docker copy command will not work if the Docker container is running. So if your container has to be shut down, and then it can physically access the files which is there in no the Docker program data files, and then it can copy files. And then there is also a problem in copying files back from container to the host. Similarly, there are challenges with respect to no editing file, because once you actually have which inside the Docker container, there is no UI. So people who are used to Windows expect the Notepad or some application which isn't there. So for Linux, there is a VI editor which is built in. But for Windows, I think we need to explore more and find an appropriate editor, or you need to copy back the files, edit it, and then push it back to them. Similarly, the storage isolation. So basically, the storage files are completely isolated. As I already mentioned, there are challenges with respect to copy or like delete files, things like that. Some commands will not work. Finally, the network isolation. So networks, you need to be aware that if you're in a corporate network, you need to be aware of the firewall, and you also need to be aware of the proxy. So if your proxies are not set on the Docker settings, it's going to be basically um, a challenge if you don't have the proxy set or proxy misconfigured. So it's going to affect not only host but also the containers, and then these problems could be very difficult to debug. And that is number one. Number two is like usually in Hyper-V um, scenario, there are like several NIC bridges and virtual switches created on your host system, as I already showed you in earlier. So you should be aware that sometimes Docker tends to pick up the wrong one. So if you have multiple, let's say you switch between your LAN and Wi-Fi, it gets confused, and then it starts assigning the ones which is not active or ones which you don't want to be to Docker containers, and then you might have problems or challenges when you have commands which want to reach the internet. So you should be aware of that. And finally, of course, the Microsoft documentation for Dockers is not really that good. Basically, when I say that good, basically there are problems. As I mentioned, that HDBs, you need extra additional escape characters. I don't know why the documentation still has something which is misleading. So you copy paste that, you will get into errors. And of course, the other nuances of Windows images. So sometimes your images itself, for me, it got corrupted, so I needed to basically, no, I actually was looking for removing the layers, which I couldn't really find correct way to do it. So I had to completely nuke everything and then reset my Docker, no, Docker installation, and then reinstall everything, delete all the images and restart it. So you should be aware of that. That's about it. And the way I actually started was basically I went through some sessions in Pluralsight. So getting started with Docker on Windows is very interesting. And then Docker networking by Niall Putin is also very interesting and basically very no, educative. But then these two combined, I think it goes on something like 11 hours of study material. So there is a lot to know about it if you want to go through in detail. Of course, there is a lot of blogs which talks about Docker process isolation, things like that. There is also this YouTube video where basically it is actually um, the principal leads in Windows, the people who actually worked on Windows Docker implementation, talking about it. Again, this is more than 45 minutes of videos. They go into the details of the architecture and so on the like. So if you're interested, you can take a look, and that will be interesting as well. Yeah, and last but not the least, the Syncfusion ASP.NET Visual Studio example, which I have actually used it in my videos. So basically, this is a post about how to create um, build a CRUD application from scratch. The reason I chose this was that no, it's not only explains you step by step, it's actually non-Docker example. So there is nothing Docker in this. So I deliberately choose this so that no, basically you can uh, choose any of your ASP.NET project, and then how you can use the content in my video to Dockerize the same. And the another reason why I chose this was like I found the examples on the net which already had end-to-end Docker built-in Docker commands, the Docker specific examples. Actually, either they didn't work or they were actually using older images, and then those were preview images, and none of them actually had a the latest basically ASP.NET 3.0, and then Visual Studio 2019, and of course the latest images from Microsoft. And a lot has changed in the last couple of years. So that's about it. So thank you for listening in. I hope this was useful, and please do share and like if you think this was beneficial. And good luck for all your Docker experimentation on Windows. Thank you.